Okay, you've got the solid here, it's got a cross section like this, so it's basically it's a prism, so I can consider it as a laminar. Okay, so this is going to be a rectangle, and this I'm going to be making a semicircle and a sector of a circle. So all the measurements are down there. I've got to find the distance of the centre of mass of the solid from AB, from that line there. I've got to find out how far across it goes. If the centre of mass is up here somewhere, then it would topple down, unless there's a force pushing backwards or pulling backwards. Centre of mass to start off with, so I'm always going to set up my table. I'm going to have the object, and the first object I've got is a rectangle, and then I've got a semicircle, and then that's all I've got, and I'm going to have the total amount. I need to put down the mass. Mass of that rectangle, where it's 20 times 4, so that's be 80. And I want to put a K in here. K will divide out, but that is the mass per centimetre squared or whatever. Semicircle, the area of the semicircle, or circle, is pi r squared, so it'd be pi times 8 squared. But it's a half a circle, so it's a half of that. I need to times that by K, and that I'm going to work it out, so it's going to make it easier. That is 100.53096. And so my total weight will be 880.53096, or K. I'll work out my x coordinate. Don't care about where the y coordinate is. So the x coordinate is centre of mass of this first shape will be there, which is 2. And the next one will be 4 plus however much I need to go through there. So that's going to be 4 plus, and then I now need to look in the formula sheet where I have a sector of a circle, radius r, angle at the centre 2 alpha. So it's 2 times by the radius, which is 8, times by sine of, well, the angle at the centre is 2 alpha, so this is sine alpha, so it's half the angle. That'd be 90 degrees, that's pi over 2, everything always in radians. And I've got to divide that bit for the centre of mass of the sector by 3 alpha, and alpha is pi over 2. And I'm going to work that bit out, and that bit there is 7.3953, and that is going to be x bar. And now I know that's 2 times 80 K plus 100.53096 times by 7.3953 K equals 180.53096 x bar, okay, x bar, and that will give me that x bar. All k's cancel out, they're always going to cancel out, but it's quite nice putting them in there, and that gives me x equals 5.00444, so x bar equals 5.00. These are centimetres, 2, 3 significant figures. So x bar, so the centre of mass along here will be there, somewhere there, maybe a bit higher, but it's certainly going to be acting along those lines there. And it's placed on a rough horizontal ground, so the object doesn't slide. So this is just about toppling, no sliding. And it's an equilibrium with a horizontal force of 4 newtons applied along CB. So CB, 4 newtons. Well, it's going to have to go backwards this way, because if it doesn't go backwards that way, it will certainly topple, because I take moments about E and everything will be clockwise. So it's going to have to go something like this, and I've got to find the greatest and least possible values. Okay, I'm going to do the greatest to start off with, and I'll do this in red. If it's the greatest, it's going to be trying to topple about E, so that's where the normal contact force will be all the way across here, and I obviously have to have friction like that. And what I'm going to need to do is take moments about E, and I always like doing this. It's worthwhile getting into the habit. It sets you going. Anti-clockwise moments, just the 4 newtons up here, so it'd be 4 times by that distance is 20 equals the weight. Oh yeah, we'll work out the weight of the solid. So this bit I should label W. That's the weight for, that'll be W times by the distance there. Well, that's 5 centimeters across to here, so it's going to be 1 centimeter. So W equals 80 newtons. That's the maximum weight. And then I'll do it in purple for the minimum weight. I'll need to take moments. And this one here, the minimum, if it will be going across there. So I'm now going to take moments about A. And exactly the same, the anti-clockwise moments are going to equal the clockwise moments. And that'll be 4 times 20 equals the weight times, and this whole distance now, so that's the distance I worked out in part 1, it's 5. And that will give me W equals 16 newtons. So this is minimum weight, and the other one is the max weight. And key things about that question: set yourself up the table when you're working out the centres of mass, and use your formula to work out, or formula sheet to work out how you find centres of mass of special shapes. And that's question 4 done.